Hello there, and welcome to another Unity tutorial. So in this tutorial, we're going to get to implementing some art for our MineAgent in our Floor is Lava game. And the way we're going to do that is we're going to create a model in Blender. We're actually going to create sort of two versions of the same model, one fractured and one not. We'll get some textures for it from textures.com. We'll create the animations for it in Unity, and then we'll just modify our code to implement those animations. So to create our 3D model, I'll be using Blender, which is some free 3D modeling software, and you can download it for free off their website. I'm actually using the Steam version, it's also free. Blender is a 3D modeling and animation program, and it's really popular amongst indie developers in the games industry. Now, I'm not going to be going too deep into Blender itself. I'm just going to be going over the stuff we need to do to achieve what we need to achieve. But there are plenty of tutorials out there on YouTube if you want to learn more about using Blender. Okay, so this is the interface for Blender. To dismiss this pop-up window here, you just click somewhere in the scene. And this is what a Blender scene looks like, right? So by default, it spawns in with a cube. Here's a hierarchy. We've got the cube selected. It's got an orange outline around it, which tells us that it's selected. We've got a light over here as well, and we've got a camera too. Now, these things are more for animation and stuff like that, and rendering. We're just in here to create a 3D model, so we're not going to worry about the light and the camera. Selecting our cube, I actually don't want to use a cube, right? I want to create basically a little sphere for our AI that will explode and fall apart when it detonates. So to delete this cube, with it selected in the scene view, you press X on the keyboard, and then you press delete to confirm that you want to delete it. So now we need to add our sphere into the scene. So there's two ways we can do this. We can go to the add menu at the top here, go to mesh, and then we're going to work with a UV sphere. The other way is just in the scene view to press Shift A, and then you get the same menu. So we go to mesh and then UV sphere. Now before deselecting this at all, we want to change its properties. So down here in the bottom left hand corner, there's a context menu, and we can open it by clicking the arrow. And this is actually, probably higher poly than we need. I'm happy with 16 rings, that's fine. But we can go 16 segments just to bring the polys down a bit. And the radius as well, we can probably change too. So the radius I'm going to change to 0.3 meters, so 30 centimeters, a foot. And this is our sphere. So the next thing I want to do is it's in flat shading at the moment, the faces, and I want to change them to smooth shading. So I need to go into edit mode. So again, two ways to do this. In the top left hand corner, we have a context menu. It says object mode at the moment. If I go to edit mode, you can see it goes into edit mode, and we have all of our vertices selected. Alternatively, again, we can just press tab on the keyboard to toggle between the two, right? Object mode, edit mode. Now, let's say, for argument's sake, that the vertices aren't selected. How do I select everything, right? Now, there's multiple ways, but the easiest way is to just use the select all shortcut while you are in edit mode, right? So A on the keyboard is the select all shortcut. So I'm just going to press that once, and that's going to select all of the vertices in the mesh, and in turn all of the faces too. So to change the shading of the faces to smoothing, we need to go up here, right? We've got all these menus. We've got vertex, edge, face. I'm going to select face and then shade smooth, right? And you can see, if we go back into object mode now, we now have a smooth sphere, which is exactly what we want. So we'll rename this object. So over here, we have, in this context menu, we have the object properties tab selected. And I'm just going to change the name from sphere, and we'll just call it bomb. So next thing we want to do is create a fractured version of this sphere. So to do that, we're going to need a add-on enabled. It's installed by default, but it's not enabled by default. We have to actually go and enable it. So to enable it, we go to the edit menu, and then preferences. And then once we're in the preferences menu, we click on add-ons, and here are all of the add-ons for Blender that are installed. So here in this, we're just going to search for cell, and you want to make sure that object cell fracture is turned on, right? And that's all we have to do. Once that's done, back in the scene, we can access that through the operator search, and I believe that's F3 by default. Yeah, okay, cool. And here I'm just going to type in cell and select object quick effects cell fracture. Okay, so here are our cell fracture properties. Now I'm not going to play with really any of the custom settings. I'm just going to set it to use the verts as the point source, and the source limit is like how many pieces are going to get generated, right? So I'm just going to set this to 10 and then come down and hit OK. And you can see that's created 10 fractured pieces. Now we're getting some onion skinning here because our bomb is still visible. So to temporarily turn our bomb off, we can tick the I, or alternatively, again, you know, we select the object and then press H on the keyboard, and now we are just seeing all of the fractured pieces that perfectly make up our sphere. So just for, you know, exporting sake, to make things export a bit cleaner, the next thing I want to do is I want to set all of these fractured pieces to be a child of the bomb. So what I'm going to do is first we're going to select all of the fractured pieces. So I'm going to click on the last one in the hierarchy, then I'm going to hold shift on the keyboard and select the first bomb cell. Then I'm going to, with control, just select the bomb as well. Now you need to make sure you select the bomb last, because the last object selected is going to become the parent. So with that done, I believe it's control P. Yep, set parent to, and we're just going to select object here. And now in the hierarchy, you can see that we have 10 children of our bomb. And that's just going to make it export, you know, a lot cleaner. And now that we're ready to export, let's go ahead and do that. So I'm going to go to File and then Export. And I want to export this as an FBX. Okay, so I've navigated to the project folder for the Unity project. I'm going to go into the Assets folder. And we created a 3D Models folder, so we'll go in there. And let's just export it right here. So let's call this enemy mine, just like that. And before I export, I'm just going to make sure the only thing I have selected here is mesh. We don't really need to worry about anything else because we haven't got any textures or materials or anything like that for this. We're going to apply all of those through Unity. So all we need to export is the geometry from this file. Next, I'll hit Export FBX. And there we go. So now let's go over to Unity and check that it's all worked correctly. Okay, so here we are back in Unity. So let's go to where we saved our 3D model under the 3D Models folder. And there it is right there, enemy mine. If we open the preview window, you can see it. Now, of course, there's onion skinning going on here because both the whole bomb and the fractured bomb are active in the preview. So if we want to quickly check those, we'll drag one into the scene. Let's just bring it up, zoom in on it, and we can expand it. And if we just disable the mesh renderer for the parent object, we can see there's all the fractured pieces. And we can, you know, bring it away bit by bit. If we wanted to, oh, that's the parent, if we wanted to see each individual piece. Now, so the next job is to apply a texture to the model. So I've gone ahead and grabbed some textures from textures.com. They're just, it's meant to be a sort of lava one. It doesn't really look like lava when you look at each individual texture, but we'll make it look a bit more like lava. It's an alternative lava texture to the one I've used in the game already here. But before we can effectively add any textures to the object, we need to generate some UV maps for it. Unity is capable of generating UVs. So if we go to the 3D model in the project window, go to the model tab in the inspector, and right down the bottom there's something called generate light map UVs, so we'll turn that on and then hit apply, and that is going to allow light to appropriately be calculated on the object, allowing the textures to be rendered correctly. So with that done, what we need to do now is create a new material to add our new textures to. So I'm going to open the materials folder in the project window, and I'm going to select the lava material here and just press Ctrl D to duplicate it. So then I'll right click on this and go rename, and we'll call this Matte Lava 2. And just because I don't know how this texture is going to actually look, we'll just reset the tiling to 1, and now we can start slotting in our textures. So the albedo goes into the albedo, AO goes into the occlusion, the height map, we'll chuck in height map. Now this mask, so this set of textures didn't actually come with an emissive map, so I'm going to put this in the detail mask, but I'm also going to put it into our emission map, right? And it looks a bit funky right now because we've got white selected, but we'll fix that up in a sec. Next, we'll put in the normal map, and of course it says the texture is not marked as a normal map, so I'll click fix now, and it'll automatically set that texture type to normal map, and the roughness we can chuck into metallic. Now before I start playing around with any of these other settings, let's see how it looks on our actual enemy. So I'm going to just bring in our enemy mine back into the scene. Let's bring him into the light, There we go. And next, so we've added all the textures, I'm just going to drag our lava 2 material onto, we'll have to add it to all of them. So I'm going to select, open up the children for the enemy mine, select the parent and all of the children, and then we can see they've all got mesh renderers. So if we open materials, we just need to change that slot there. So I'm going to drag in matte lava 2 to that, and that's changed the materials for all of them. The next thing I'm going to do is just disable all of the fractured objects. And now we have no onion skinning, and we're just looking at the mesh. So let's select matte lava 2 again, and let's play around with some of this stuff. So first of all, let's just change the emission color. So I'm going to make mine like orange, right? And you can see that's obviously made it look a lot more like lava. It's a bit too intense for me, so I'm going to drop the intensity of the light down. Let's drop it to 1.8. Yeah, that's pretty good. Maybe slightly more yellowish kind of orange. Yeah, that looks good there. We'll leave it at that. Okay, so that's the color done. Next, let's have a look at the height map. Let's see how much influence this has. Looking at the preview window here, it doesn't have too much. I might just crank that all the way up to Mach 1, right? And if we get a bit closer, maybe we can see it in effect. Let's just turn off the grid. Let's have a look at that again. Okay, height map. I might just crank that all the way up. We've also got ambient occlusion, which probably won't have too much difference because of the lighting in our scene. We can see it has more difference down here in the preview window. So we'll just leave that at 1. And then we have the smoothness. So that's going to determine how light reflects off it. That looks alright. Let's just set it to a flat 0.5. 0.5. Whoops, 0.5. There we go. Alright, 0.5. Alright, so the next thing we'll just quickly check is the normal maps. I don't usually adjust this. Sometimes you can get more bumpiness out of it, but it goes overboard real quick. So 0.5, 1.5. See, the higher the number, the more impact the normal map will actually have. So 1.5, that actually, it's not too bad. What if we bumped it up even more too? Oof, I don't know, that's going a little overboard, I think. Let's set it to like 1.25, 1.4, 1.4. All right, there we go, 1.4. And we can just check the actual albedo source for the metallic map as well. Doesn't really seem to have too much difference with this set. That's all right. We'll just leave it as metallic. But there we go. So that's our mesh done for the AI mine. So let's just copy this. So I'm going to right click on it in the hierarchy, the parent, and select copy. And now what we need to do is add this to the prefab. So in the project window, I'm going to find our prefabs folder and go to the MineAgent prefab and just double click on that to open it. Next, I'm going to right click on the MineAgent object and select paste as child. And now you can see, although the Y value is offset, so if we bring that back down, the mesh is now a child of our MineAgent. So what we actually need to do here now is remove the mesh from the parent. So I'm going to go back to the MineAgent object, right click on the mesh renderer, click remove component, and the same for the cube mesh filter, right click and remove component. So now this object is only responsible for collisions and navigation, but because this object is a child of it and its position is set to 0, 0, 0 in local space, it's going to follow the MineAgent object around the scene. Actually, one thing we might as well do as well is we'll just zero out the X rotation as well. Okay, so now I can click back and we can delete this enemy mine because this is just the mesh. This isn't the prefab, the one we were working with before. So we'll remove that from the scene. And now I want to bring in a MineAgent, and this platform here, is that a moving one? Oh, that's a moving one. We won't do it on that one. This platform, let's do it over here. Okay, right here at the end. So I'm going to drag a MineAgent into the scene, and you can see when we do that, it's dragged in with its new mesh. Now we could also drag in the MineAgent resume behavior variant, and that's also dragged in with the mesh because this prefab is a prefab variant of the MineAgent. So any changes we make to the main MineAgent prefab will also be made to the MineAgent resume behavior prefab. Okay, so we have our MineAgent. Now we just need to set him up. So let's just move him into position. Yeah, and we need to set the bound box and all that sort of stuff, right? So at the moment, where's our bound box? It's somewhere. Let's zero it out. So if I zero out the center, that should go to 0, 0, 0. Do we have our gizmos turned? Oh, I had my gizmos turned off. Okay, there we go. So turn my gizmos on, and now we can see everything again. Yeah, there's the bound box there. So let's just see where that was. Oh, that actually was kind of close to where we needed to be. All right, so let's just back it up a bit, push it over. Oh, not that way, this way. And we might expand it a bit too. We'll give them a big possible area. All right, there we go. Okay, so the last thing that we need to do before we can enter play mode and test the MineAgent and make sure it's all working in the scene is bake a nav mesh. Now we've already made everything in the scene static, I believe. Yeah, that's static. If we select the room static. Yeah, so everything's static. So if we go to Window, AI, Navigation, and yeah, go to the Bake tab and just hit Bake, we can see it generates our nav mesh, but there's a problem here. all this area on the lava that's blue has been deemed walkable. So the reason for this is because our room is marked as static, and because it's static, it knows it doesn't move, but it doesn't know that the AI can't walk on the lava. So to make the room unwalkable, or the area of the room unwalkable, in the navigation tab with the room selected, we go to Object and we change navigation area to not walkable. And now if we go back and rebake our nav mesh, you can see that only the larger islands have a nav mesh. So with that done, we should be able to go into play mode and test out our enemy agent. Okay, so we can see our enemy agent is moving around in the scene. Apologies for the lag. My laptop is dying in the heat here today. But yeah, the MineAgent has resumed its behavior, and it has a mesh following it around. And what happens if we were to go over to it? Oof. Oh no, it's really laggy. Almost too laggy to play. Alright, there we go. If we go over here, does it detonate? Yes, it detonates. It still affects us. Good, so it's all working. So the next thing that we need to do is create an idle animation, a moving animation, and an armed animation for our MineAgent. So to do this, I'm just going to open the animation window. So from the window menu, we go to animation and then animation. And we'll dock this by our game window because we'll need access to the scene window while we are animating. So next we'll open up the MineAgent prefab by double clicking on it in the project window. And here we go. So here's our MineAgent. Now we aren't going to animate the top level object, right? Because the top level object is driven by code. Its position and all that sort of stuff is driven by code. And if we animate it, then the animation won't ever work properly because the code will be overriding it. So we're going to select the enemy mine object, which is the one that we are going to animate. So with this selected, let's go ahead and click on create to create a new animation for this object. Now we haven't made any animations yet, so I'm just going to create a new folder in our project and let's call it animation. And this is the only animated thing for my project, so I'm not going to bother making another folder for the enemy agent here, the MineAgent. But if you have different animated things, you would create different folders, one for each. So here, let's call this anim_enemy idle. And if we have a look at our project window, we can see there's an animation folder. And that first animation has actually created two files. So this here, anim_enemy idle, is the animation file, whereas this here, enemy mine, is an animation controller, which is used to control which animation an object is currently playing. So we'll deal with that later. So selecting the enemy mine in the hierarchy again, we can also see in the inspector that it's had an animator component attached to it, and the controller for the animator component is the enemy mine animation controller file. Again, we're not going to worry about the animator just yet. All we're going to do is animate this object. So to do that, you can see we've got anim_enemy idle selected. We hit the big red record button to enable keyframing for our animation, and we can scrub along the timeline here by dragging along the top where the timestamps are. And I'm actually going to move the scrubber to 20 milliseconds here. And the way I want to animate my object here is I want it to move slightly down, right? So this is our idle animation. So we're just going to have it kind of moving on the spot. So the Y value at this point in the animation should be minus 0.25. And you can see that that has, if we scrub through our animation, it's created a keyframe right at the beginning of the animation to store the initial position, right? And then it's created a keyframe to store the Y value at this point in the animation. And if we scrub through, we can see the movement that's generated as a result of these two keyframes. So next, actually, let's just define the end of our animation. So to make this seamless, we simply select the starting keyframe on the very first frame, and let's copy that. So we can right click on it. Can you not copy keyframes that way? Right click, no. Okay, so we'll select it and go Control C to copy. And then let's scrub along to the 1 second mark and Control V to paste. And now you can see that there's movement being generated all the way through the animation. So we're not quite done yet. I'm also going to move the scrubber to 40 milliseconds, and here I'm going to give it a Y value of 0.25, positive 0.25. So we basically have this seamless up and down motion. Now, one annoying thing is that there's a bit of an ease in out and out at the end and start of the animation. So to fix that, right, we go to curves and select our position, and we'll just shrink the scroll bar here so that we're dealing with less space and we can see the graph more clearly. Okay, so the reason that easing in and out is happening is because of these curves. You see at the start and the end, there's a slight sort of curve. If we select, it's really small, but the handle for the final keyframe there, and we just straighten it out. Oh, I've selected, oh, that's the wrong one. Click on the green line first, and then click on the handle. There we go. Now we can straighten that out to about 45 degrees, and we'll do the same for the start as well. Right, and now if I hit play, you'll see, oh, there's still a little bit of a lag, but it's a bit more consistent. So, you know, we could just play around with this a little bit more. Let's see how that looks. Okay, good. So now actually I've got a bit of a hang around the top and the bottom, which is actually kind of what I want for this animation. So if we go back to the dope sheet down the bottom, we can see our keyframes again. Now the next thing I want to animate is the scale, right? I want to slightly animate the scale. So at the 20 millisecond mark, let's just say the scale is going to be slightly smaller than what it currently is, right? So we'll set it to 80. And then at the 40-second mark, actually we'll have to do the scale between. So to move this scale keyframe and not everything, if you click on these keyframes at the top, you select all of the keyframes for every property in the animation on that point. But if we want to select one in particular, we just click on the one that aligns with the property that we want to move. So for this case, it's the scale, and I'm going to actually just move it to the 10-second mark, right? Cool. And then I'm going to select, again, just the scale property on the first frame, Control C to copy, move my scrubber to the 20 millisecond mark and paste it in, and then probably the same for 40 and the same for the end. Then I'll copy the one at the 10-second mark, paste it in at the 30 millisecond mark and the 50 millisecond mark. And now we've got kind of this pulsating going on, right? Now that is probably a bit too much for my taste, so we might just adjust things slightly. Right, so it's just very slowly going to shrink and get bigger. Now, if we wanted to make this animation slower overall, because right now it only goes for 1 whole second, we can highlight all of the keyframes and then scroll out with the mouse wheel. And to evenly stretch this out to the 2-second mark, we'll click on the bar at the end here and just move it until we're at the 2-second mark. Oh, I think I just went over, there we go, 2-second mark and release. And as a result of that, it'll be a much slower animation, Cool. So the scale is a little bit too uniform for my liking. Again, if you can't see it when you swap over to the curve sheet, you just need to zoom out your scroll bar. So let's just muddy up some of this scale here. And we've actually got 3 axes being animated, right? So we can animate them independently. Say if, okay, we're working with the x-axis here. Let's just maybe drop that out. And, you know, maybe this one here. Let's grab the middle one and like sort of make it a bit awry. Do this one the opposite way. The most important thing is that you don't move the position of the actual keyframe, right? You can adjust the curves all you like. Here we go, that's what I want, something a bit like kind of wonkier. Let's do the Z kind of maybe the opposite direction. Let's boost that. And by making them all transition at different rates, you'll see, let's turn off that. We actually get kind of like a, it's not as, it looks more organic because everything's moving kind of independently, right? Again, if we go back to the dope sheet, select everything and maybe stretch that out to even 3 seconds, just so you can see what I mean. Yeah, it's a lot more organic looking, right, as a result of modifying the curves for each axis independently. All right, so that's our idle animation done, right? It's just moving up and down on the spot. So we can uncheck the record button. So that's one animation. Next, let's do the move animation, right? So I'm going to click on this drop-down menu here and click Create New Clip. And I'm going to call it Enemy Moving. Okay. And then, yeah, let's get stuck straight into it. So I'm going to hit the record. And let's just move our scrubber to the halfway point here. Now, when we're animating the movement, we need to consider that the movement is not controlled by the animation. So we don't want to actually move the object forward or anything during the animation. Otherwise, the mesh might move outside of the bounds of the collider. So when we're creating the animation, we just want it to sort of be like moving on the spot, right? My animation might even be very similar to the idle one, but slightly different. We'll try and give it a bit more emphasis to make it feel like it's moving a bit more. So first of all, we'll move to the 30 millisecond mark, and let's just, you know, maybe we'll move it up by 0.3, slightly higher than the idle. And in fact, we'll bring that to the 20 millisecond mark. Then we'll move to the 40 millisecond mark and put in negative 0.3 for the Y. And then, you know, I'm just going to copy the keyframe from the start. All that's changed is the Y position, so we could come to the end and just say Y. Actually, we'll just do that. Y is equal to 0. So now those two keyframes match, and we'll have a seamless loop. Again, same issue as before with the curves, so we need to smooth things out a bit. Okay, there we go. So we have a very distinct like hanging in the air and at the bottom. So that's going to kind of simulate the motion of flight. All right, now let's go back to our dope sheet and let's change the scale next. So in my case, as our object rises, I want the object to shrink, and as it falls, I want it to expand to sort of, you know, look like it's getting heavier. And that's the reason it's falling. So at the 20 millisecond mark, we are going to just decrease the scale of the object. We'll make it 50, make it half of its current size. Then at the 40 millisecond mark, we are going to make it 100 again. Actually, let's make it 150. Actually, we'll make it 120, not too big. Right? And, you know, we'll just copy the scale keyframe from the first frame and paste it on our last frame. And the result, all right, so it looks kind of static at the moment. We need to adjust the curves for the scale to make it look a bit more lifelike. So let's go and do that. Go to the curves tab, zoom all the way up, zoom out a bit even. There we go. Make sure we select scale. We can even open the scale so we can select each axis separately. So let's work with the x-axis first. And yeah, I'm just gonna kind of go random with it, to be honest. That looks pretty organic and lifelike. I'd say that's a pretty good movement animation. That's another one done, so we can go out of record mode there. And the last animation is going to be the armed animation for when the player gets too close. So let's create a new animation, enemy armed. Save. And this one can be a very simple one, right? So let's just hit record. And what are we going to do here? I don't think I'm going to actually animate the position here. Let's just stick with the scale. So let's make the scale like 75 halfway through the animation. And let's just copy that first keyframe and paste it the 1 second mark. All right, so now we have this looping scale. And that might actually not even be quick enough. So let's just highlight everything and push it down to 45 milliseconds. Yeah, maybe a little smaller, 40 seconds. All right, that's pretty good. Okay. So we've got the scale changing here. Now I also want to animate our materials emission, right? So again, we've got the enemy mine selected, and in the inspector, if we're in record mode, so it's tracking all of the changes that we make and trying to turn them into keyframes. And we can actually do that with the properties of the material, right? So in this case, all I want to do is change the emission color. So I'm going to click on the emission color. Again, my scrubber is at the 20-second mark here. And let's make it like red, right? There we go, and you can see that's created a keyframe here for the materials emission. So if I copy the first keyframe for that and paste it at the end, as a result, we now have this flashing animation, right? Where the material is actually animated as well. So let's just go to the curves and let's, you know, play around with the scale here. Yeah, nice. Oh, actually we have, that one might not work so well. Let's change the end here. I think that's making the seam very noticeable. Okay, cool. That's a bit better. No, maybe this one too. That might be a bit extreme. There we go. Okay, so we now have all three of our animations done. Now what we need to do is actually set them up in the Animator. So there are two ways we can access the Animator. We could go to Window, then Animation, and then Animator. And then we would have to select the object that has an Animator component with the animation controller that we want to edit. Or we could just find the animation controller that we want to edit in the project window. Here it is, Enemy Mine, and double click on it. And that opens the Animator window. So this is a finite state machine. So these are the states, and each state is an animation. And only one animation can be active at a time, right? Just move these around to a nice order, cool. So this green tab here that's linked to the default state, which is the first state that the animator will enter when the game starts. And if we wanted to change the default state, we could right click on it and click set as layer default. But I want the enemy idle animation to be the first one that gets entered. So we also have this blue any state box here, and when we make transitions from this state to one of the animations, it basically means that we are making a transition from any other animation to that animation. But to give further control over how the animations are played, we also have parameters. So in the animator window, if we click on parameters, we've got a list here. It's currently empty. We will define two parameters in a second, but these are used to control how transitions activate, basically. So let's go ahead and just click the plus here, and there's 4 types of potential parameters. We've got floats, integers, booleans, and triggers. We're going to create booleans for this tutorial. So the first one we'll call, how come I'm not naming it? First one we'll call moving, and we'll create another one, and we'll call this one armed. And they're the only parameters that we're going to need. So actually, let's just go out of record mode for this animation and stop it playing, because we don't need to edit it anymore. So the next thing we need to do is start creating transitions. So first of all, let's create a transition from any state to moving, so we can go into the moving animation from any other animation, right? So we do that by right clicking on the any state bubble and select make transition, and then just clicking the state that we want to transit to. And if we click on the arrow, we can see all the parameters and settings for this animation. So if we open the settings here, there's a few other things that we can turn on, and then down here are the conditions under which the transition will occur, right? So this is where we use our parameters. So let's go ahead and click the plus here. And we're only going to have one parameter. It's going to be the one that's automatically been set by default. So we're going to set the moving boolean to a value of true when we transition into this state. Or sorry, when we're only going to transition into this state if the moving parameter has a value of true. Okay, so next, let's just come up to the top here. Let's turn off can transition to self, right? Now we're going to activate all of these transitions through code, and we don't want to be able to transition into the moving animation if it's already playing, right? So we can't transition to the moving animation from the moving animation. The next thing we'll turn off is fixed duration, right? Because we don't want the transition to play over a set amount of seconds. We just want it to occur for a portion of the overall animation. And this percentage here, that changed when I turned that off. So before it's in seconds, when you turn it off, it's a percentage of the overall animation. And in this case, I'm going to set it to 0.1. So it's going to be 10% of the animation to take the transition. And the next thing is the offset. And I'm going to set this to 0.3. Oh, not 1.3. 0.3. And that just defines how far into the next animation, in that normalized percentage, how far into the next animation that it will start playing at. Okay, so we have a transition into the moving state, and we can go into the moving state from any state, but let's create another transition from the moving state to the idle state, and then we'll select it. Now here, we are going to turn has exit time off, as well as has fixed duration. I'm going to set the transition duration to 0.1 and the offset to 0.5. The offsets are something that you probably want to play around with in play mode to see what feels right. You can also check the preview if we had a model selected. So if I select my model here and then go back to the animation, transition, we can see that we can see the model, and we can actually see what the transition will look like. Actually, okay, so these values work for my previous one, so I'm probably going to have to check these again. That's alright, that's not too bad. Okay, so that's all those properties set, and there's no can transition to self setting for this one, because that setting only exists for transitions that occur from any state. But we do need to set conditions for this, so I'm going to hit E+, and we only want this animation to play if, moving is equal to something, but only if it's equal to false, right? So we can only transition from moving to idle given that moving is equal to false. Okay, so next we'll create a transition from any state to the enemy armed animation. And we'll turn fixed duration off and can transition to self off. And all I'm going to do here is I'm going to change the transition duration to 0.2. Let's hit play and see what that looks like. That's not too bad. There we go, that's a bit better. Okay, so we've got a transition duration of 0.2 and a transition offset of 0.1. The next thing we need to do is add a condition here, and all we're going to check for is that armed has a value of true in order to transition into this animation. Next, we'll create a transition from the armed animation to the enemy idle animation, and we'll turn off has exit time and fixed duration, and let's just hit play and see what that looks like. That looks pretty good. Okay, next we need to add two conditions here. One, we're going to check that moving is equal to false, and we're also going to check that armed is equal to false as well. Now we need to make one more transition, which is going to be a transition from armed to enemy moving, and it's going to be very similar. Again, we'll turn off, did I turn off exit time? Yep, okay. Turn off exit time, fixed duration, and let's add two conditions first. So again, moving is going to be true this time, but armed is going to be false. So they're the two conditions for this transition. Now let's hit play and see what the transition looks like. Maybe, can we shorten that? No, 0.2. That looks pretty good. I'm just going to leave it at that. Okay, so before we wrap up all the transitions, we should probably check the first transition we defined from any state to the moving state. So I'm just going to select that and hit play. It is a bit sudden, a bit jarring. Okay, so I'm just going to reset this back. That looks pretty good. Now we can actually preview it. It's currently previewing from the idle state, so we can preview it from another state. So let's preview it from the armed state. Let's see what it looks like going from armed to moving. That's pretty good. Okay, so the default value for transition duration there would have been fine. And now that we've done that, that's all of the transitions defined. And we already know that our enemy mine animator has the enemy mine controller set as its controller. So we just need to set up the code to trigger the parameters that will cause the animations to play. So to do that, let's select our MineAgent object in the prefab, and we want to open the MineAgent script here. Okay, so the first thing that we need to do is define a couple of new private serialized floats. So underneath detonate radius, we'll create a new serialized field, private float, and this one will be called detonation force. And we'll give this a default value of, I don't know, 50. Then immediately underneath that, actually we'll just duplicate that. So I'll press Control D with my cursor on that line to duplicate that variable. And this second one we'll call respawn delay. And we'll give this a default value of 1, but we can change both of these values in the inspector. And we should probably give them a tooltip, so I'll copy one of the previous tooltips, and we can just replace the string here. So detonation force defines the force that is applied to each fractured piece upon detonation. And we'll do another one for respawn delay. And this one will just say defines the amount of time that will pass before the object is disabled. Okay, so scrolling down, we're also going to need some private variables. First of all, with the rest of our reference variables, we're going to have a private animator, and we'll just call this anim. Now we're also going to have a private rigid body array, and we'll just call this fractured pieces. And then with our value type private variables, we're going to have a private boolean, and we'll just call it dead and give it a default value of false. So we have a reference to the animator to play the animations through. We have a reference to our fractured pieces rigid bodies so that we can add a force to them, the explosion force, and then we have this dead parameter so we can stop certain behaviors while the mine is detonating. Next, let's scroll down to the awake method here. So in the awake method, what we want to do is first set our animator variable. So we're going to say anim is equal to. Now, if you remember the hierarchy of the prefab, this script is on the root object, the very top object, the MineAgent object, whereas the animator is on the first child. So here we want to say anim is equal to get component in children, and that's component singular. And here we're looking for a component of the type animator. Underneath that, we want to set our fractured pieces variable. Now, we haven't done this in the inspector yet, but we will when we finish up the script. We need to add rigid bodies and colliders to each of the fractured pieces. So in this case, we're storing them as rigid bodies. So here we want to say get components, and that's components, plural, and we're looking for rigid bodies, just like that. And that returns an array. If we mouse over it, we can see it returns an array, so we can store it in our array variable. Now, the next thing that we want to do is we actually want to loop through each of those pieces and disable them at the beginning of the game so that they're not visible. So here we'll say, well, underneath that line we'll say for each rigid body, and we'll just call that RB, or no, we'll call that piece in fractured pieces. So we're looping through every rigid body in our fractured pieces array. And here we want to say piece. So for the piece that we're currently looping through, we're going to have to get access to the game object of that piece, and then call setActive and pass it a value of false. So that loop will disable all of the fractured pieces, each game object at the beginning of the game. Okay, so next let's move down to the update method. So the first place we want to look to modify is this section here, right? This else statement. So here we're checking if the remaining distance to our destination is less than the stopping distance, the AI stopping distance. If it is, we know we are within range of a new point. If the timer is greater than or equal to 0, we're going to increment the timer a little bit. If it's greater than or equal to idle time, we're going to move to a new position. Otherwise, if the timer is not greater than or equal to 0, it means the timer is turned off, and here we turn the timer on. So what we also want to do when we turn the timer on is turn our moving parameter on our animator off. So first we want to check to make sure we have an animator. So we're going to say if anim is not equal to null, right? And if it's not equal to null, it means there is an animator. So here we'll say anim.set bool, because our moving parameter was a boolean, so we want to set a bool. And this takes two parameters. The first is an ID, and we can pass this as a string, and this is the name of the parameter with the exact casing and spelling as we defined it in the animator. So ours was called just moving, all lowercase, and we put a comma after the string. And next is the parameter. Do we want to set it to true or false? And in this case, we want to set it to false because we are just beginning to idle. Now, to make things easy on me, I'm just going to highlight that bit of code we just wrote and copy it. And copy it. Because what we write in a few of the other places is going to be very similar. Okay, so let's move down to the onTriggerEnter function, right? And the first thing I want to do is we actually want to modify this if statement. Right now it's just checking if the colliding object is equal to the player. The other thing we want to check at the same time, so we're going to check a second condition here. So to do that, we follow the first condition with two ampersands. And here, we just want to make sure we're alive. So we're going to say if dead is equal to false, because we only want to react to things entering the trigger while the mine is alive. So next, we can leave those two lines. They're fine. We turn the timer on and we set agent.isStopped to true. The other thing we want to do is we want to stop walking, right? Agent.isStopped means we've stopped moving. The AI has stopped moving. So we want to set our walking boolean to false on our animator. So I'll just paste in what I copied before. So this line here, we'll set moving to false. So we'll stop moving. We also want to set another parameter to a value, which is our armed parameter. So if this method is firing off, it means the player has entered the trigger, in which case our AI will become armed. So we'll set armed equal to true. And that's all we need to do for onTriggerEnter. And we'll do a similar thing for onTriggerExit. So if the AI is set to resume its behavior when the player exits the trigger, and the object leaving the collider is tagged as player, again, we want to make sure that we're alive to react to this. So we'll add another two ampersands after that second condition to check yet a third condition. And here, just like before, we're going to make sure that dead is equal to false. Okay, so next, underneath the two lines of code we already have within this if statement, we just paste in what we had before. So first of all, we'll change this to armed, and this is on trigger exit. So yeah, we want to set armed to false, right? Because it is no longer armed. But next, we want to open an if statement, and here we want to check if agent.remaining distance is less than or equal to agent.stopping distance, right? And if it is, I'm just going to copy this line here and paste it in. If it is, we are also going to set moving to false. And the reason for that is the update method will detect that, it'll resume the update method because it will no longer be detonating, and it will detect that it is within range of its target, and it'll call an idle, and then it'll automatically start moving again when it starts moving to its next target, which is the next part of the code that we need to look at. So after that, let's just move down, and we're going to look at the move to new position method here. So here, I got rid of what was copied to my clipboard, so I'm going to have to write this out again. So we'll say if anim is not equal to null, so if we have an animator, We're going to get access to it, and we're going to set a Boolean parameter called moving, and here we want to set it to true, which will cause the moving animation to start playing, or to be transitioned to from whatever the currently playing animation is. Okay, and that should be all of the places that we need to call the animator parameters, but what we do need to do is add the force when we detonate to all of our fractured pieces. So let's just scroll down to the detonate method. So all that the detonate method does right now is using an overlap sphere, detects the colliders that are within range, checks if any of them are the player, and if they are, it subtracts a life before disabling the game object. So we're going to change the nature of this a little more. So first, let's just go to the top of our method, and I'm going to create an if statement here. I'm going to check if dead is equal to false, and I'm going to open the coding brackets, delete the last one, come to the end of the detonate method, and I'm going to put that last one back in to auto format all of my code via Visual Studio. So now this code can only be called if the AI is not already dead, right? So next, what we need to do is underneath this for each loop, we are going to do another for each loop. So we'll say for each rigid body, also again we'll call it piece in fractured pieces. So we're going to loop through each of the fractured pieces, and first of all let's say piece.gameobject.setActive true. So that's going to turn that game object on. The next thing I want to do is we also want to set the parent to this object, the MineAgent, which is the one that has this script attached, because at this stage they are all children of the model that we made. So to do that, we say piece.transform.setParent, and then we can just pass it transform with a little t to pass it this object's transform. So this object will become the new parent, and we can happily turn off the old parent. Then the last thing that we need to do is actually add the force to each piece. So here we'll say RB, we'll say the one called RB, it was called piece, and we'll say add explosion force. So rigid bodies actually have a function for explosion forces. And here we pass it three things. We're going to pass it our detonation force as the first parameter to be added to each piece. The second one is going to be the origin of the detonation, which will be transform.position, so the position of this object, and the radius here will be detonation radius, and we can close the line. So then underneath that for each loop, we have this line here, which disables the game object that the script is attached to. Now in this case, we don't actually want to do that. What we want to do is we want to disable the same object that the animator is attached to, because all of those children were children of the animator. So we can just say anim.gameobject.setActive false, which will turn that original mesh off, which is fine at this stage because we've made its former children of this object now. But the next thing I want to do is here I'm just going to write a comment, and we're going to say start coroutine to disable whole object, and I'll explain that in just a second. Then underneath that we'll say dead is equal to true, and then lastly we'll say enabled is equal to false. And what enabled is it enables or disables the mono behavior. So this script, so it's basically like turning the checkbox for the script on the game object on or off. So we're basically disabling this script, right? Okay, so the next thing we'll do is we'll create our coroutine. So underneath our detonate method, we're going to create a private coroutine, which we do by giving it the type enumerator, or the return type, and let's just call this disable after time. Set of parentheses to follow the name, and then the coding brackets. Now we'll get an error to begin with because it'll say, this coroutine doesn't return a value. So a coroutine basically needs to give, to pause its execution at a certain point and return control back to Unity for, a certain period of time before resuming execution of the method. So here, all we're going to do is we're going to say yield return new wait 4 seconds, and in here we'll just pass it respawn delay. So this line is basically saying when we get to this point in the method's execution, which will be right at the beginning, the coroutine will give control back to Unity for however many seconds this variable represents. When we get control back from Unity though, we want to disable this object. So here is where we'll say gameobject.setActive false. And that'll turn off the object that this script is attached to, which is the root object for the enemy. So it's going to disable every component associated with it and all of the children. So it's effectively removing it from the scene. So now all that's left is to call this. So we'll replace our comment here and we'll say start coroutine and open a set of parentheses. And now inside these parentheses, we just call the coroutine as if it was a regular method. So we'll say disable after time with an empty set of parentheses because it has no parameters, and then close the line. And now that should be everything that we need to actually test the functionality. So let's save the script and go back into Unity. Okay, so I'm back in Unity. We have our mine prefab open still, which is good because what we need to do is we need to add colliders and rigid bodies to each fractured piece. But if we just have a look at the MineAgent where the script is, we can see we've got some new parameters, the detonation force and the respawn delay. But yeah, so let's open our enemy mine. And now I'm just going to select the first fractured cell piece here, hold shift, and then click the final one. Now these are already turned off, we turned them off earlier. We could re-enable them temporarily if we wanted to, but we don't need to at this stage. So all we're going to do here is click on add component because we want to add a component to each of them. And here we want to add a mesh collider. Now what a mesh collider is it generates a collider for each piece. So I might actually just turn off the mesh renderer there, and let's just turn one of these guys on. Okay, so a mesh collider, we can't see it at this stage, but it's actually generating a custom mesh based on the exact geometry of this mesh here in the mesh filter. So in order for this to work with a rigid body, because mesh colliders, they do work with rigid bodies, but they need to be convex, which means they need to have this property turned on, right? So let's select all of them and just turn convex on. And as soon as we do that, you can see that we actually get a visual representation of the collider in the scene. And a convex collider is basically just a collider that's calculated on the average of your geometry, your shape's geometry, right? So now that we have convex mesh colliders on each of these pieces, we need to add a rigid body as well. And I'm just going to leave this as default for now. We definitely want use gravity on. We don't want to constrain it at all because we want these pieces to go kind of flying everywhere. But you can play around with like the mass and the drag and the angular drag to see how that impacts your explosion as well, right? So with that done, I'm actually just going to disable this bomb cell again. And now we can exit that prefab. And do we have a MineAgent here? There it is. Let's just preview the settings again one more time. So detonation radius of 3, and a detonation force of 50 with a respawn delay of 1. Maybe we can give it a higher respawn delay. Let's say a respawn delay of 5 seconds, right? We'll say 3 seconds, of 3 seconds. So, all that's left to do now is to actually play the game. Actually, before we play the game, we do have to fix one thing. I noticed on my MineAgent that the mesh render is turned off. So let's just open the actual prefab. Open prefab. And let's just turn mesh renderer on again. Exit the prefab so we can see our mesh renderer now. Good. So yeah, let's hit play. Okay, let's turn our gizmos off. So we can see the animations are playing and transitioning to one another. That's good. If we wanted to watch our character in real time, we could open the Animator here and then select the enemy mine with the Animator, and now we can see the animations transitioning in real time here, right? Now I think I'm probably, oh no, I've got enough time. So let's go over here and see what happens when it detonates. Oh, okay, didn't seem to work. Wonder if that's because these objects are turned off. Let's try again. Okay, let's try that again. There we go. So those objects had to be turned on before the game starts. And of course the script turns them off. And we can see after a certain amount of time passes, the MineAgent object gets turned off. The next thing we should check is that it reacts if it has its resume behavior toggled on. So we'll just turn that on and give that a go. Okay, so if I navigate to the AI and then, yep, looks like it's going back to the correct animations. Awesome. So there you have it. So that's going to be it for this tutorial, guys. If you found this useful, please leave a like. And if you want to see more game development tutorials like this, feel free to subscribe. We've got one more video to go in this series, just covering audio. And then I think it'll be done and we'll move on to creating some other games. So yeah, thanks again for watching. Have a good one.